I'm not teaching you polarization and Doppler effect. These are newer topic lah. So you refer to the note that I've given you earlier lah. If you want me to teach you, I can review with you lah. Okay. Usually examiner will try to set two topics together lah. Combine into one question lah. If they can lah, if possible, rather than a pure question. Okay, so these are some of the things that you need to know about waves lah. Velocity is frequency times wavelength, and how to calculate phase difference between 2 points, right? In terms of time and period, in terms of distance and wavelength, and longitudinal wave, transverse wave, and then we can represent that displacement distance graph, or we can represent it with displacement time graph. This formula not necessary lah. They will give you if they require, but this one you need to remember. Okay, this summarize for you your new syllabus. Right, summarize for you Victoria form. Diffraction is the spreading of wave from the geometry into the geometrical shadow as it passes through a slit. So you have to remember narrow gap. Narrow gap means that the aperture size is approximately equal to the wavelength. And the other one is where the aperture size is very much greater than wavelength. And the application is a television wave has a shorter wavelength compared to radio wave. Right? So of course, this is the shadow of the hill. So television wave cannot be obtained by a house here, whereas radio wave can be obtained by the house here because of diffraction. And then you need to know for interference, you need to know what is interference. When two or more waves meet at a point, there is a change in overall intensity of displacement. Superposition tells us how to add the waves. Interference tells us what we see when a wave crosses. Coherent is a constant phase difference between the wave. Condition for wave to interfere, both waves must be of the same type, meet at a point, same direction of polarization. Then you need to know what is the antinodal line, lines where reinforcement of wave occur or constructive interference occur, right? Where there is your nodal line. This is your antinodal line, where your antinodal line is where constructive interference occur, whereas nodal line where destructive interference occur, maximum and minimum meet. And then you need to remember this formula for Young double slit. And then you need to know roughly the magnitude of the slit spacing distance there, or from top to the bottom here. Right? It's about 0.5 millimeter. Capital D slit screen distance is about 2 meter. And then the fringe spacing Y or X, right? Fringe spacing given as formula, you have to remember. The aperture size this aperture size, usually it should be the size of wavelength, but it's not possible to do that. That's why our aperture size we use is about 0.1 millimeter. Okay, so you need to know all this, what does it stand for. And then you need to know the center one, the path difference 0, and then the first destructive interference occur where the path difference half lambda. That means wave coming from here travel longer distance compared to wave traveling from S1, right? The path difference is half lambda lah, extra distance travel lah. Okay, so this is just a repeat. Okay, what is the answer for this one? Yep.
Interference. B. Boy.
Okay, we are now on page 279 lah. In case you are using your working sheet. Okay, B, good. Polarization only affect the transverse wave. This one you need to remember lah. What is the answer? Yep, what's the answer?
D.
Okay,
Donkey.
donkey, correct. This one, the wavelength keep on increasing lah. This one, the wavelength also changes as it pass through. So donkey is correct. Wavelength does not change after diffraction. A is for small gap. Right? This is not small gap. Small gap, the size should be almost different, but this one show the wavelength is changing. How about this one? Right? We are told at which distance from the slits would the fringes of the same separation, y is constant, we observe when using blue light of the same wavelength. So they are using the same double slit. So A is a constant. Okay, so it's basically using this formula. Lor. Right? Ya is constant, so D of lambda is a constant. So D2 lambda 2 equals to D1 lambda 1. So put in your value, lor, 400, 400. D2 is what we want to find. And then D1 is 1 meter. Lambda is 600. 1.5 meter, donkey. Okay,
Okay.
this one. Don't use the idea of path difference. Right? Wave travel from S1 to P, S2 to P. So what happened to here? Right? Each generator, amplitude A. So find the path difference. No? A, path different, S2P minus S1P, 5 minus 3 is 2 meter. Right? Then compare with the wavelength. Wavelength is 4 meter. Wavelength is 4 meter, so it's half a wavelength. Half a wavelength means destructive interference. So it will destroy each other. The two waves are 180 degrees out of phase, so destructive interference. Okay.
Mm.
Try this one. Same idea. Find the path difference. No? Right? 100 minus 80 is 20 millimeter. That's the wavelength. 40. Right? You have 40. So it's 0.5 wavelength. So it's destructive interference again. No? So it's 180 degrees out of phase. No? Okay, now examiner can twist the question around.
What?
Instead of destructive interference, using path difference, in terms of lambda, you can use phase difference. Phase difference is 180 degrees out of phase. No? Yep. What is the problem?
The formula is d lambda over.
This one is we want to compare with the wavelength. So we times wavelength divided by wavelength. No? Say 0.5 lambda. No? Or half
Oh,
lambda. No? From here you can see 20 millimeter compared with this one is half lambda. No? So if it's 0,
okay.
if it's 0 or 1, if it's 1, then it's constructive interference. No? How about this one? Okay, so there's your source S1, S2. This is where the central maximum. It decrease to 0 here. So what's your answer? Then this is the first destructive interference. This is the central maximum. So you subtract S2x minus S1x is half of the wavelength. C.
Y half.
Okay,
Y half.
sorry, can't hear you.
Y half.
First destructive interference, constructive interference, the
If
first
it
one is
says
0. First one is 0. The next constructive interference will be lambda. Destructive interference where the maximum meet the minimum, or the two are 180 degrees out of phase. Okay, you cannot.
okay.
This is 0. The first destructive interference is half lambda lor. That means this S2x minus S1x is half lambda lor. S2x minus X1x is lambda is the next one lor. Where you have constructive interference lor. So we are more interested in constructive interference, destructive interference, constructive interference, destructive interference. So as long as it's half lambda or 1.5 lambda, it's destructive interference lor. Okay,
Oh,
a surprise, why you always so poor when I give you the assignment, you can do it. The best one.
those were quite simple lah. This one is quite hard. The
Oh,
paper one is usually hard.
okay. This is so many. Right? Y is
Yeah.
proportional to wavelength and inversely proportional to frequency. So which change increase the separation between the dark lines? Right? Same as bright line. Roughly can use the same formula, roughly the same idea. So using monochromatic light of higher frequency, however, frequency is smaller wavelength. So cannot be. Using monochromatic light of longer wavelength, yeah, Y is proportional to that. It's decreasing the distance between the screen and slit. That one is D. So you want this one to be increased. So wrong. Increasing the distance between the slits. That's your A. You increase it, this one becomes smaller. So no, the answer is B. Yep, yep, yep.
Diffracted lights reducing wait.
Increasing the frequency of vibration means you decrease the wavelength. So this one decrease the wavelength. This one becomes bigger hole, bigger gap. Increasing the speed of the wave by passing the water in the tank deeper doesn't affect. Reducing the amplitude doesn't come in. Right? Amplitude will be the same. Reducing the length of the vibrating rod, it just affect this length that's all and this length that's all. Answer is A. Okay. Okay, okay, no, not okay. You ask question.
Yeah, can you hear me?
Answer is A.
Can you
If
hear me?
yeah,
Oh, I was responding. How come you can't hear one?
You increase the frequency means you reduce the wavelength, no? Frequency and wavelength are inversely proportional. Right? You reduce this wavelength, this becomes wide gap. Same like this one, no? Yep, whatever, don't understand us until you are happy with it.
Sure, I think you can't hear me, right?
Say again, I can't hear you.
Oh my gosh. Yeah.
Can or not? Can understand or
I'm
not?
responding, but I think you couldn't hear me.
Initially couldn't hear you because it was too soft. Now can hear you already, speaking louder. Okay,
Yeah.
okay, have a go at this one. Frequency is given, the picture, frequency of the light. This is your A or D. This is your A. That's your capital D. Show that the width of each slit is approximately 160 times the wavelength of the incident light. This one straightforward lah. Usually you have to calculate the wavelength first. Frequency is given. That's your V or your C. Right? Speed of light. Then calculate the wavelength. Then this slit divided by the wavelength. Give you a number of wavelength. Can
Yeah, okay.
and explain why the pattern of fringes on the screen is seen under limited area of the screen.
What's that mean?
You don't see it, you don't see an infinite fringes, so you see a limited fringes. It's related to this question now. It's considered a wide gap already. Right? So compared to the wavelength, this is a wide gap. Right? Pattern is seen due to diffraction at each slit. For large amount of diffraction, the slit width must be the size of the wavelength. Right? But we are not using that. The diffraction is very little. This is not so here. So very little diffraction because of wide slit. Region of interference is also smaller. No? Okay, now
Yeah.
calculate the separation of the fringes observed on the screen. This one is memorizing the formula, right? Capital D is 2.6. Lambda we have calculated out. A is given there, so it's 1.1 millimeter. Can
Mm.
the intensity of light inside a double slit is increased? State the effect, if any, on the separation and on the appearance of the fringes.
Decrease in separation. Hey, no. Oh,
You must always go back to this formula. Right? Go back this formula. Separation is not affected by intensity. Right? Fringe separation is unchanged. Brighter fringes, right? More light can pass through. Brighter, as more energy can pass through. Dark fringes stay dark, not darker. Dark fringes stay dark. That's all. Dark is dark, not darker. Okay, or not?
mm.
State three conditions that must be satisfied in order for that the two waves may interfere.
Longitudinal wave. Wait. Interference.
Both transverse or both must be of the same type. Both transverse or
Yeah.
both longitudinal or same type. Meet at a point, they must meet a point before they can interfere. Same direction of polarization. Okay,
Is transverse and longitudinal the same thing?
different. That means transverse and longitudinal cannot interfere. These are alternative answer.
Oh.
Both of them transverse or both of them longitudinal or both of them the same type. Okay.
Mm.
Okay, the picture show you already all that is required. Suggest a suitable value for separation A of the slit in the double slit. Right? You need to know the magnitude. So there's a range of value. And remember, yeah,
Total value.
0.3 millimeter to 3 millimeter. What's the relationship between lambda, A, D, and X? Memory work. You see, this is very simple sometimes.
Lambda over A.
Yeah, that's the formula.
Or D lambda over A also can, right?
D lambda, D lambda over A equals to what?
D lambda over A. D equals to
D
X.
lambda over A also can equals to X. Okay, also can, yeah. As long as it's the equation anyway, you write it, okay. Describe the effect, if any, on the separation and the maximum brightness of the fringes when the following changes are made. Right? Use the formula where D is increased to 2D, keeping A and lambda constant. Yep. What happened to the separation?
Larger separation
Brightness?
remains the same.
No? Further away.
What?
Further away. So the intensity becomes smaller.
Oh.
Okay. Intensity is inversely proportional 1 over D squared. Wavelength is increased from to 1.5 lambda, keeping A and D constant. Separation?
Separation decrease.
Separation increase.
Maximum brightness.
Maximum brightness. This one is not in the syllabus. This is the old syllabus, so it's not in yours. You don't require to know the intensity is proportional to frequency square. Intensity of light incident on the double slit is increased, keeping lambda and D constant. Separation, you got less than 10 minutes left.
Um, Intensity, I think separation, nothing changed. And then maximum brightness increase.
Brighter.
Ah,
You increase density, more energy pass through, so it's brighter. Lor. Okay,
yeah.
I think I may have to take another 20 minutes or so. Lah. Okay, shows the wavelength emerging from the double slit. The wavefront represents successive crafts of the wave. The line OX, that's the line OX, shows the direction, shows one direction along which the constructive interference may occur. Right? They are very kind to you. State the principle of superposition.
When two waves superimpose to each other.
So, what do you do?
Uh, I
Two
forgot
or more
the
waves meet.
principle.
Don't use superposition already.
Oh,
Superposition is not a clear term for them. Examiner don't like it. When two or more waves meet, the resultant displacement is the sum of the individual displacement. Right? Draw lines to show a second direction along which constructive interference may be observed. Label CC. Direction along which the destructive interference may occur. Label that DD. Right? That's where you have DC, constructive interference, maximum, maximum. Right? You have to imagine in between is the minimum. So
yeah.
minimum mean maximum is DD. No? Okay, not?
Wait, teacher, isn't D supposed to be like lower?
Huh? D is
Isn't D
supposed to,
supposed to be lower?
D D is supposed to be a line where the destructive the minimum is here, meet the maximum, no? Minimum meet the maximum. Here also minimum meet maximum, no? So this is a line, no?
But why is it not looking like C? It doesn't
C
look like a
constructive
reflection
interference
of C.
C is maximum, meeting maximum, maximum meeting maximum, wavefront meeting wavefront, so it's constructive interference, so this is destructive
But
interference, DD.
all destructive, right?
Ah,
Okay. Oh yeah, I get it.
right, same lah. They will require you to use the formula to calculate, lor. They have given you the distance. There's A, there's the wavelength. So the free separation, right, which is 0.7, calculate, just use the formula, that's all. Right? Is given, right? 650 nanometer, change it, 1.2, is A, 1.1, 10 to the power minus 3 meter. Okay,
Yeah.
the width of both slit is increased without changing the separation. A, state the effect, if any, that this change has on the separation of the fringes.
Separation on fringes
As
increases.
long as
Brightness
A is
of the
constant,
light fringes.
no, it doesn't change. No change.
What?
As long as A is constant,
Oh,
A is constant, right? Go to the formula. It's always go back to reasoning using this formula. If D is constant, A is constant, you increase the size only. You allow more energy to pass through. Okay now. Brightness will
Yeah,
increase though. Brightness of dark fringes,
remains the same.
dark becomes dark, no change, remains the same. Okay, I think we have enough already. Let's go to okay, I might want to use another 10 to 20 minutes. So I'll give you 15 minutes break to do some of the problem on standing waves. Condition for standing wave, the two waves of same type, speed and wavelength, traveling opposite direction, cross a region, right? Must cross the same region. A new waveform is produced. Right? Principle of superposition, when waves meet at the same place at the same time, the resultant displacement is the sum of the individual displacement. And this destructive interference is constructive interference. And this, all these facts must be in your head or work it out If you cannot memorize it, then know what is nodes. Points where the displacement is permanently zero. Antinodes are points that have a large amplitude of vibration. Distance between two successive nodes is half lambda. Distance between nodes and antinodes is a quarter lambda. And this is the difference between progressive wave and standing wave that you need to remember. Okay, try this one. Remember, during the break, try the following question again. I want to take another 10 to 20 minutes, finish it. Yep, what's the answer? Find the wavelength. Right? From a node to first node, second node, third node is a wavelength. No? From a node to two antinode to a node